Charges. As you can see, I've added questions at the beginning of the video. Compared to last term, the videos had the questions at the end. Now I'm using them as priming questions. And remember from the previous video that you need to, at minimum, write these questions down and attempt them. Do not just leave them blank, and do not just neglect to write them down at all. So use these questions to help your mind to pinpoint important items from the video to help you to focus during this time. All right, so let's keep going. So how are charges created? What is the smallest charge possible? What types of materials would make good conductors and insulators? What is the difference between conduction and induction? All right, to prime us, we need to go back to chemistry. And so if you think back to the atom and the parts of the atom, we have three main parts: the electron, the proton, and the neutron. And if you look at these, you can tell that two of them are charged, one is not. The neutron is the one that is not charged. The neutron goes in the center, in the nucleus, as do the protons. So the protons that are positive are in the nucleus. So the nucleus has an overall positive charge. The electrons, however, have a negative charge, and they are not in the nucleus. They are spinning and moving very quickly outside of the nucleus in what we call electron clouds, or in these orbitals. And they are moving very fast, very close to the speed of light, and they are moving in very specific shapes that are predicted by quantum mechanics, a really cool area of physics, actually. And so this is a simplified diagram of what we see here and of the orbitals. All right, let's keep moving. Along with chemistry, what do you know about the charge of a proton compared to that of an electron? So proton compared to an electron. And for this, I want you to think back to your ions. If you think back to your monatomic ions or your polyatomic ions, if you have those memorized from last year, you can think back to the charges and how you counted the charges, and it's simply based off of the number of protons compared to the number of electrons. What this implies to you is that the charges have an equal magnitude. So you'd have a +1 or -1 or -4 or -3 or +2 based off of the ratio of the protons to electrons, so they have an equal magnitude. The magnitude of their charge is here. So this is in coulombs. The coulomb is the unit that we use, the SI unit, the metric unit, for measuring charge. The magnitude of the charge of an electron is 1.6 times 10 to the -19th coulomb. This is the magnitude, so this is just the value. If we're speaking specifically of an electron, we're going to put a negative here. If we're talking about a proton, it's going to be positive. So, to one of our priming questions, can there be a smaller charge than this? This can actually be a bit more complicated depending on how deep you go, but this will also help you to think about the calculations that you do later on when solving for your charge of an object. So, we're going to talk about this, and you want to talk about this in your small discussions in class. So these are another two models of the way our atoms are, and this actually shows you the predicted shapes of the orbitals based off quantum mechanics and the probabilities of where the electron will be 90% of the time. So let's keep going with this. Creating charges. Before we can talk about creating charges, we need to talk about the law of conservation of charge. And so just the term conservation should give you an idea that things cannot be created nor destroyed. So during any process, the net electric charge of an isolated system remains constant. So there are a few keywords here. So during any process, so when something happens, the net charge, the total charge of an isolated system remains constant. So here we have to be careful with the way we define isolated. An isolated system is however we define the system, meaning we can define it as two objects, or a room, or the globe, or the solar system, or the universe. Within whatever isolated system that we're talking about, the net electric charge, the total charge of the system, remains constant. So you might be wondering, so how do things get charged? So if you look at the picture here, we have this girl who has rubbed the balloon on her head, and you can see that the balloon now has a charge. we can define the system to be the girl and the balloon together, and all we've done is move charges from the girl's hair onto the surface of the balloon. The total charge of the girl and the balloon together haven't changed. All we've done is moved where the charges are located. And to see another example of this, I have this quick video. And you see this girl, she's getting out of her car, putting gas into her car, and then you see her get back into the car. And then a moment later, you see her get out of the car and reach for the gas pump. And then all of a sudden, you see flames. And just so you know, this is not what you should do. You should just hit the red pump stop button and you should leave. All right, so what happened? If you think of our system, the system was both the girl and the car, and maybe the whole gas station. The total charge of that system is constant, but charges were moved around, and then they rebalanced themselves when she touched the handle. So to think more about this, we need to think about this idea. So the way we create charges, all we're doing is separating some of our electrons and moving them to a different objects. Friction is what does that. So friction between two surfaces force these loose electrons to move. These loose electrons are the valence electrons, going back to chemistry. These are the electrons that are very easy for the atoms to give up, to give away, in order for them to retain a full shell in some cases. But these are the valence electrons. And friction is what does this. It's what moves the electrons, the valence electrons, from one object to another. And if you think of lightning as another great example of this, the accumulation of charges inside a cloud are due to the friction from the dust, from the ice, and the water droplets, things that are in the air. As they move across each other, charges are moved from one side to another side, and you actually have clouds that are positively charged and other clouds that are negatively charged. And so you can actually have lightning go from cloud to cloud, go from cloud to the earth, and even from the earth to the cloud. And so the system still remains constant in its electric charge. These electrons are moving within that system. Conductors and insulators. Conductors are any substance that easily conduct electrons, and insulators are essentially the opposite. Substances that are poor conductors of electrons. In fact, they are typically used to restrict the movement of electrons. And the question that I want you to leave you with is, what do you think about superconductors, this term, and semiconductors? And this will be before we move on to the next topic. All right, there are different ways of charging. We have conduction and induction. Conduction is the transfer of electrons between two objects, and induction is the electrons that move within an object. An electroscope is something I'm going to be showing you in class. This is a device that detects a charge. So we have a conducting sphere, we have the conducting stem, an insulation between the box and the stem, and then we have foil leaves on the bottom. So this is what it looks like, and this is what you'll see in class. Now what happens with this, if you can visualize it, by itself, when it's neutral, it has an even number of positives and negatives, so protons to electrons. When we bring something close to it that is charged, we can move some of these charges around. And you have to think back to what we said, moves. The protons remain in place. It's the electrons, these valence electrons, that move. And so, for example, we can have these electrons that would move down to the leaves, or electrons that would move up to the conducting sphere. When that happens, anytime there is a charge on this electroscope, these foil leaves, going back to this, these foil leaves will have the same charge, and when you have the same charge, they will repel each other. And so when they are charged in this conducting sphere to the conducting rod to the foil leaves, When it's charged, you will see movement within these two foil leaves. Now, in class, what I want you to think about is how you would be able to tell the difference between conduction and induction using an electroscope.